Hey everyone, how's it going? Welcome to the stream. Oh, my camera's a little bit off there. Okay. All right, so since the last time I streamed, sorry, actually, let me just recap what I did last time. So last time I worked on displaying structs. Yeah. So let me give a little demo of what that looks like. So here we have our Vectrex C++ program. We've got like an enum here, a struct called bar with 3 values, a struct called foo. Now foo has a bunch of different values, a float, a bool, that enum value up here. It has a bar, which is another struct, so a substruct. And then it's got these bit fields, which don't quite work yet, and that's all right. And then we have a simple function, and anyways, we instantiate that foo here, and we start populating values in there and all that. So this is what I got done last time. So if I just make sure this builds. All right, hit F5. And there we go. So let's see what this looks like. As usual, we've got our local variables here, and this is what we're working on. We go in there, and then here we have F, that's our foo. As you can see, it displays its members, A, B, C, D, E. Right now they have garbage values. It even expands bar with X, Y, Z. And then we start populating values, and you can see that all the members get populated. You also see that D and E, which are our bit fields here, don't get the right values, and that's pretty much expected. In fact, what's interesting is you can see that D here got set to 4 and E to 0. So let's see if we can make sense of the fact that it shows 16. So yeah, I suppose what's happening here is that we've got 2 bits for E, the low bits, and 6 bits above it are we set a number value 4. So, oh no, so most likely what's happening is D, those 6 bits are at the low end, and then 2 above. And then, because it's allowed to order them as it wishes. And actually, no, I'm not quite sure what this means. Anyway, it doesn't really matter. So yeah, this all works. So what I wanted to do tonight, it might not be as interesting in the sense that I'm not sure if I'm going to get to the point where I can add new functionality, but what's next on my list for structs is there's a whole bunch of stuff here. I got to add support for pointers, for bit fields, and all kinds of stuff. Now just for this, I need to reuse code for parsing pointer local variables. So this brings me to my Rst Parser. I think that in order to get to the point where I can start to reuse code here, I actually need to start refactoring this code. So this has just become a very nice and long function here. You can see all this. That's a lot of code for just one function. I mean, it's still understandable, but it's difficult to reuse, starting to become a little bit difficult to read and understand. So I think what I'm going to do is I'm going to do a little bit of cleanup, a little bit of refactoring, add some member functions. This is pretty much a class that has a constructor and a single function, and everything is pretty much in that single function. Yeah, I have like a few utilities and an anonymous namespace up here, and some constants here. But yeah, I need to start splitting out some stuff. So I'm gonna start working on that tonight, and we'll see how far it takes me. All right, so let's see here. Yeah, I'm gonna start by just may as well move this here. Why does it say namespace here? That's kind of funny. Something went wrong with Clang format there. All right, so let's do this. Get line This is probably going to mean I'm going to have to move a lot of for declarations, perhaps some includes, but that's all right. That's all part of the thing here. So getLine returns a bool. Okay. Next up, we're going to start getting to the meat of all this. I have a bunch of these functions for parsing. Yeah, this one I think. Okay, yeah, what I'm going to need to do is move these into, make these data members over here. A little bit of renaming. Just prefixing all of these with my m underscore so that I know these are members. Okay, let me do the same here. Okay, so this should build. Maybe not. Let's see what's going on here. Right. So we've got unordered map. In fact, obviously it should be here, or maybe I'm getting these out of another header, I guess. Memory, I need a vector. Also, these types, function, scope, and all that, looks like I'm going to have to include my debugger and debug symbols. Okay, that still builds. Good. So yeah, refactoring is not always the most interesting thing, but it is really a big part of development. So every once in a while, I got to do some cleanup so that I can keep moving forward. So it's gonna be like one of those episodes. All right, so the next thing I'm going to do is I have a lot of these functions here that are local functions scoped for when we add symbols. I'm going to make all of these functions. There's a lot, so this is going to make a big difference in terms of cleaning up this code. So let's come down here, convert my convert these lambdas into proper functions. So I have the return type here, so I can just grab that. Oh yes, and I need to add Rst Parser. I also realized I was using the lowercase naming convention for my functions. I'm gonna have to change that. I think this is a habit that I've been picking up from work where we do this. I actually do prefer this naming convention, but I haven't done it in the rest of my code base, so I gotta stick to what I got here. Yeah, I'm gonna have to add this up down here. Good. All right, the next one is here. So what are we returning? We're returning a type. Shared pointer to this. Whoops. In fact, I think I want to return a shared pointer to type. Or maybe no, enum type is fine. Yeah, that makes sense. Let's see here. Okay. So these are all very similar. This guy is going to be 1 for struct type. Shared pointer indirect type here. Fact. All right. All right. So this returns, this is void, I suppose. If I do need it to return the variable that I just added, I guess I could do that. But I do not need it, so there's no point in changing that. Okay. This should build. Good. All right, so now a little bit of renaming. I would like to use my rename feature, but it doesn't always work. So let's see, if I do this, does it do the thing? But why didn't it do it here? See, it did it in the Rst Parser, but it didn't do it here. That's strange. See, the rename functionality here is not, it's doing it in the CPP file and yet not doing it correctly in there. So you can see it here. Anyway, it's actually not so bad. Okay, yeah, do it in there as well. All right. So I'm going to keep my little state machine here. All that's going to stay inside this function. That's fine. So the part that I need to reuse is coming up here. Let's see. This part. All right, so what I wrote here is that the type finding code, move the type finding code into add indirect type. So I think what I'm talking about is this part here. So what I do is I look for the type, I warn if it's not found. So could I easily add that into add indirect type? Let me see. I'd have to pass in the type ref ID, obviously. So that's easy. I guess the problem is if I don't find it, what do I return? I suppose I would have to return something null and check for that. So that's the only thing I don't like. Oh, I guess I could if this, then do that. Because if I did that, at least I'd be able to reuse this function in the case of parsing members of a struct, which is the goal here. But then if I do that, that's the thing. I do this kind of searching for types in multiple places. The alternative, I suppose, is to try to, make this a little bit cleaner. So what do I do here? I get the iterator, and then I get the second. So maybe I could do this a little bit differently. Let me see. Where am I doing this? So I've got one here that looks pretty much exactly the same. Here for variable declarations, that looks very much like the same thing. I get the type ref ID. And then here I return, otherwise I do add variable. So add variable would also get the type ref ID, and I would do the same code there. Okay, yeah, let's make this a function. I wouldn't be able to say type not found for. Yeah, that's another thing here, is that I'm actually displaying a nice error message for the variable that I'm finding it for. That's the one thing that I would lose. If I put it in add variable, I could do that. I guess I could pass in the variable name. We always are trying to find a type for a given variable anyway, right? For a given variable string, variable name here. Or member name, in this case. I guess I could just say for %s. How about that? Even a member name is really a variable. It's a data member variable. Okay. Okay, let's do that. And ultimately, in all cases, I just care about the second member, which is the shared pointer to type. This is a string. Actually, I'll just call it find type. Yeah, I don't like when there are variables that are not necessary for the function, but maybe I could do this. Let's see here. Something like this. Okay, so now we can use this function this way. So we'll do if auto type equals to find type, type ref ID, so we'll do the same thing here, followed by the member name here. Okay, so let's say if we found it, it means we got a non-null shared pointer back. Then we set member.type equal to to this type we just found. Indeed, I could even move it here. And then do a pushback there. Of course, if I didn't find it, I should be returning. So that's a little bit messier. Unless I don't return. That's also possible. So I guess I would keep going for other struct members. That would be one advantage. Okay, let me just comment this out. So it would be something like this. Right, that's what I thought. Because there is a previous type. Let's see. 285. Right. Okay. I'm even thinking at this point that maybe I should do the find first, because if I don't find it, none of this is necessary. Oops. So do I want to add a struct type that has a member that's unknown? I suppose all that means is we just won't show it. So it's not like it's unsafe. All right, let's do it another way. Let's go like this. Ah, yes, and then the member name is here. Okay. We'll just go with the way we were doing it here. All right. So next place to replace is here. When we add variables, let me keep all this code here just for reference. Otherwise, we call add variable, and then this here becomes var type. Okay. Our else and pointer. Oh, actually, hold on a sec. I forgot that I wanted to pass the variable name here. Yeah, and then here too. Okay, let me just make sure I did not break my debugger. Looks like everything's the same. That's good. Yeah, it's cool to see the hovering work as well here. In bar, you can see that it gets expanded properly. I don't know if it's supposed to show something up here, like, I guess this would be the string if there was one over here. I think. Not sure. Yes, there would be, I think. I don't actually show a string for those, so that's why, yeah. Okay, so looking good. Let me then erase that stuff. I'm still thinking that I want to push this information in there. the other thing I'm thinking is maybe I'd like to, in terms of refactoring while I'm at it, it would be nice to like split up what's going on inside here. So if I've got an LSIM match, the only thing about this is I'd like to keep my match stuff private for now. So it's going to be a bit more difficult for me to refactor this. See, like, let's say I wanted to take this chunk of code here for when I know I'm dealing with a type definition, right? So all this code here uses this LSIM and it accesses values out of there, like type name, type def ID, has range. Then maybe it's going to call range lower bound, range upper bound. So one option is that I do expose this LSIM match type up here so that it's visible in the header file, and so that, although actually I guess I could take it by ref and just forward declare it. Yeah, I guess that would work. Yeah, I don't need to actually make it visible. So what am I saying? It could be opaque in the header file. Because see, if I do that, then what I like about it is that when I'm parsing my struct, I can try to do an LSIM pointer match, I think, at least partly. Oh, hey, thanks for the follow. Mistakes being made. Appreciate it. Right, so yeah, so I was saying is I could maybe reuse that by trying to create a match out of the portion of the string that I have for the data members. If it is a pointer, then I can just call that function to like handle LSIM pointer match. Although that function would need to take a, well, it would need to do all this bit here. Which brings me back to maybe I should just, I don't know, I'll do this. On the fence, on the fence. You know what? Give me a moment. I'm just gonna go get some water. Okay. Let me take a look again. Let's see. So here is what I'm talking about. Here I'm collecting members, and find the type of this member. Yeah, that's the thing. It won't find it for pointer types because pointer types are weird creatures that both add a type. They both declare and define a type for the variable. So let me take a look again here. So let's say we go back to our struct example. See, I had taken off this int star p. So if we add it back and compile this, so let's see, no, not this guy. Oh yeah, it's going to be at the top here. Oh, well, glad you're here, man. If you have any questions, don't hesitate to ask. So reteaching, right? So you used to program in C++? What have you been doing since? Okay, so this is the part I was talking about. The p:28 equals *7. So this here is exactly what I match, the kind of thing I match with the LSIM pointer match. And I need to check for that when I'm parsing my members here. And in fact, I believe I said last time I would have to probably change my LSIM struct match so that I could get back that portion. Let's see, how does this work again? Or maybe it's out of value match here. Let's see. Right, because I get all of this, right? Or not. I get member name. Member name, type ref number, offset in bits, and size in bits. Yeah, it's useful. But actually, this match doesn't actually work correctly for this case, does it? This matcher. Let's see. So let me add my pointer type in there. Or let me take this string here. Two semicolons. Okay, so it does get matched here. 28 equals, so this is not quite right. Finished my degree in CS in 2019, but haven't touched C++ in several years and didn't feel I learned enough, so I'm starting back from the beginning. Currently a sysadmin, but looking to transition back into software dev or software engineering. Sounds like a great plan. especially if you did a CS degree. Well, welcome to the stream, man. Or woman. Sorry, call everyone man. Don't mean to assume anything. All right. So yeah, this is not going to work because this is going to match the wrong thing here. John Hillington 2, have you worked with FPGAs before? I have not. I know what they are, but I'm not actually really I'm not really a hardware person, although I like hardware, which is why I write emulators, I suppose. But I'm definitely more from the software side. Must I? Why must I? Just curious what you think. No, I mean, yes, I know. I know that it's not fair to call it purely hardware, obviously, but it's the name programmable is in there. It's like somewhere between software and hardware. Yeah. One thing I know that's built with the FPGAs is I forget the name now, but there's this like NES FPGA thing. Yeah, the NT Mini Analog, this guy here. This guy, I find really interesting. A little bit expensive, but it's a cool project. Looks like there's quite a few. There you go. Oh, maybe that's what the Mini is. Anyway. Yeah, maybe this is a bit more. What's cool about this is that it's really all FPGA, so the entire hardware of the NES has been programmed into this thing. I bought this sketchy Chinese dev board. It has everything in Chinese. Oh, nice. Yeah, because see, the thing about this guy is that maybe instead of doing value matches like this, oh yeah, because I do need to get the offset. So maybe what I need to do is just extract this first part as one field, not like member name type ref ID, although the member name is kind of useful. Yeah, maybe at some point I'll look into FPGAs and mess around with them. In fact, I think there is someone trying to do an FPGA of the Vectrex. Maybe I'm wrong. Oh yeah, I think it's this one. The Mister. This one here, yeah. So the Mister, I think, is some kind of like multi-emulator thing. The Mister system is basically a hardware clone of each of the computer or arcade games it supports. So there you go. Yeah. You add these daughter boards. So you see it, you get this DE10 Nano FPGA board, and then you add I/O boards. You add all a bunch of stuff to it, and you can add cores. Now add system cores to your Mr. SD card. Oh, so that's it. And then this basically will program it to run different systems, which is pretty cool actually when you think about it. Yeah, my friend of mine sent me this a little while back. Right. The risk of working in hardware, right? Okay, so yeah, what I was trying to say here is that rather than extract this bit here, which, you know, if it's a type ref, it's going to look different. I should reuse the code I have up here. So let me see if I can do that. This I could match it. This maybe, yeah, this I would be able to match it as well, right? Int, well no, this is a type definition, never mind. But for local variables, this would work. A:7. So I could try to match it as an LSIM match, and if I've got that, I can say, all right, add this as a local variable. Although it doesn't define a type, and I don't really want to add a variable, I want to add a member. So John Hillington, you want me to review code here on stream? Not usually something I do here. I could maybe take a look like off stream if you want. Is there anything in particular you're looking for? So this is what you shared here. So you're writing a read-write lock for IPC. So you're using the semaphore, the system level semaphore thing. So that, yeah, between processes you can access the semaphore. Yeah. Yeah, I think that's what this member is, if I recall there from create semaphore. So one thing off the bat is I think you could just call create semaphore without the A. If you're getting problems because you're using std string and it wants a wildcar, that means that you're compiling in Windows, you're compiling your program where the character type is, well, I guess your type is set to Unicode instead of ANSI, so that's why it's picking the Unicode versions. So probably you should be using Unicode in that case. Anyway, this is another option. This is forcing it to use the ANSI. I suppose that's all right. This is more Windows programming than C++ though. Yeah, I don't know this API super well. Like, this looks all right. So here you're doing your wait when you construct a read lock in your destructor. If I should get used to this. I don't even use no except yet. Like, destructors can't throw exceptions anyway, right? So does it even make sense to add one on a destructor? I don't even know. You want me to look at your R value stuff? Let me see. Deleting your copy and assignment. You actually did make here a move constructor for your type. Are you actually using this? Are you doing moves with your IPC read lock? You are, okay. I mean, this looks all right. I guess you're doing std exchange. Is this is this like thread safe? Is that what you're doing, or you just wanted to swap the two? I don't even know what std exchange is. You might know more C++ than I do now. Oh, that's nice. There you go. It actually says to use it for your move assignment and move constructors. Beautiful. Oh, because it does the forwarding for you for the new value. Oh, that's kind of nice, actually. There you go. You taught me something. Learned it from a YouTube video. Oh, was it that one that came out recently? I saw on Reddit there was a recent video of a guy explaining R values and stuff. So yeah, this looks right. Although I think for assignment you're supposed to do the check that you're not equal to yourself. Normally that's what we do in the move assignment. So you can even see it here in the example. If this is not equal to address of other, so you just don't want you want to avoid doing a self assignment, right? Because otherwise you'd be exchanging move n while leaving 0 in other.n. Right. So that's the thing. If you do self assignment, you're going to end up putting 0 in yourself, I think. So yeah, just add that in here. Well, yeah, sure, but I mean, anyway, at least add an assert if you don't want to put the check, you know, just in case somebody ever does it, including yourself. The right lock sketchy. So you actually create a named mutex, then you create a named semaphore. This mutex is to avoid multiple writes, I suppose. So if already exists, I mean, honestly, like maybe like I'm too tired to like kind of work through whether this logically is correct. I can tell you that the C++ looks fine to me, but logically, I don't know. Maybe. This looks okay. Looks clean. Yeah, it looks good, man. Like I said, apart from the self-assignment check, either you add that or put an assertion or something just to make sure. I mean, everything looks pretty clean to me. If no semaphore exists, one is created with 0 count. And not much. I did start learning Rust. I started doing the Rust book. I think I got to like 5-6 chapters in or so. And I liked it. I wasn't motivated to keep going because I didn't have a project in mind. Yeah, I think I may have heard about it. So the doubly linked list paradox. Is it that problem of like ownership and like the problem is in Rust, a reference to one thing, having a doubly linked list means like you have references to each other. And so that means that object A owns B and B owns A, and that's not allowed in Rust or something. Because you have to have like a very clear single owner, so you can't do cycles, and the borrow checker will figure it out, something like that, right? They claim unsafe Rust is as safe as C++. Okay, makes sense, I guess. I mean, if unsafe Rust is not being checked for stuff like all the memory safety stuff that it's supposed to be checking for, then yeah, I suppose it becomes like C++. I suppose the only thing I could argue there is that at least in C++, if you're using Clang, you can, and even GCC, you can take advantage of a lot of the sanitizers that have been added to the language. I don't know if Rust has those things. Since Rust can do so much at compile time, right? It's the whole idea behind Rust is to check for these things at compile time. I don't see them spending a lot of time writing additional runtime checks for unsafe code. Whereas for C++, since the default is like none of that memory safety is checked at compile time, there's just a lot of tooling that's been built. A lot of these sanitizers have been built into validating, use after free, doing unsafe stuff with threads, stuff that is like guaranteed by the safe part of Rust. So you could claim that if you write a lot of unsafe Rust, then it's actually less safe than C++ if you're using sanitizers in C++. You're asking me about Visual Studio performance? Yeah, it's all right. I don't have too many problems with it. Sometimes it's a bit slow, but it's totally workable. If you watch my stream, you'll see I make do. And the thing is, I have a pretty crappy machine on top of that. If I had a better machine, then it'd be even better. But even with my crappy machine, it's totally workable. I think with the size of programs that I write, it's not so bad. And to be honest, Visual Studio has gotten a lot better. If you keep yourself up to date in 2009, they've been making a lot of efforts to improve the compiler speed and stuff like that. Yeah, 2017 is okay, but there's been a lot of improvements in 2019. You should be able to just upgrade to it because it's like, 2019 is just like, in fact, I think they're, yeah, the binaries that are produced with the compilers are backwards, like, what's the word I'm looking for? ABI compatible, right? So they produce ABI compatible binaries. So you're worried about the CRT, the runtime. So another thing you can do is actually you can use VS 2019 for everything and just tell it to use the platform toolkit from 2017 for compilation. So you won't get the benefits of a better optimizing compiler, perhaps a more compliant compiler, but you'll get all the improvements that have been made to the tooling, the IDE, and there's been a lot. It's a lot more responsive. You're saying that 2019 doesn't support the Intel compiler as a platform toolkit? Oh, that's strange. I would have thought Intel would keep their stuff like really up to date. Okay, so let me actually commit as is before I continue to do more refactoring, because I think this might be enough for me to at least start testing out the reuse of the pointer thing and see how that goes. So I'm not actually using Clang. I have here though a Clang build. I haven't built this in a while, so most likely this is going to bork on a couple things. That's the the built-in support for Clang's compiler there, which is kind of nice. See, this is Clang 10 here with the MSVC-like command line. So I haven't built this in a while, so I'm almost certain it's going to start like failing on a bunch of stuff. But in general, I continue to use the MSVC compiler. And the main reason I do that is because the reason I like Visual Studio is for its debugger, and I know that the Clang compiler, although it does produce PDBs now that are that work, there are a few things that are missing or not quite right. So the debugging experience is not perfect. So yeah, there's not much gain for me in using the Clang compiler here. The reason why I added it though is because, there you go, you can see some problems here, is just because I do intend to eventually have this thing running on Macs. So I like having it compile with Clang because that gets me closer to making sure it compiles on Mac with Apple Clang. Oh yeah, okay. See, I'm actually super close because I went through and I did a pass. This would just be doing this here, if I'm not mistaken. And there you go. Yes, I know. The sanitizers are truly amazing. What's cool is VS 2019 is going to add like native support for those sanitizers. They're going to make it super easy to like select Clang as your compiler and then actually enable sanitizers within the IDE. So there's like a lot of good stuff coming. Microsoft has totally embraced Clang, so it's pretty impressive. Let me go back here. So yeah, there you go. So I was very close to still having it compile. at some point I have to like go back and fix my CI. I'm using Travis and AppVeyor to build for Windows and Linux, and I know like I recently broke them, and I just need to spend some time fixing them. And part of that will be to add a config to use the Clang compiler. So that'll be something that make sure Clang still builds, and then I can be happy with that. All right, so let's just see here quickly. Did I leave anything that I shouldn't have? Okay, looks good. Just check something. Yeah, technically, this guy is not used anywhere else, but okay. Okay, looks good. All right, so let's see what I can do now about my value match here for structs. Yeah, really on the fence about how to do this correctly. Let me just try something. I just want to see, is it just pointer types that are like, I think it's just going to be pointers that are going to be weird. Okay, so this is what I'm thinking here. I'm thinking that what I want to do is, let's say instead of member name and type ref ID, these two would disappear, and I'd have a function that's more like var decal or something like that. Is that what I would call it? Which is not exactly a variable declaration in all cases. Maybe it's more like an LSIM. Let's say it's this. So an LSIM, basically what I'm talking about is all of this stuff is LSIM, right? LSIM match here to match like local variable declarations or whatever. It can match pointers, technically enums and all that, but those wouldn't appear in there, I believe, because it'd be a separate one for that. So it's really going to just be for those two types. So let's say we call it an LSIM, I don't know what, LSIM string. Okay, let's just leave it like that. And I don't have it returning anything just yet. To do it, I'll have to change the way I match. But the idea is to return this string here. And if I copy, let's say, my pointer type, semicolon, something like this, then it would return like, oh no, that's not quite right, like this. So then that LSIM would return, say, this guy here. Or something like this. Now, why I would do this is that, let's say I have that code, I have this function, then what I would do is over here, right now I'm calling member name, I won't do this. I would start off by saying, all right, values.lsim of I, and then I would try to use my matchers, just like I was doing up here. But there's only two that I think I ever need. It's this one, and more now I'm thinking I do want this in functions, because then I could reuse some of these names, because now this is like a name clash, you see, with the one above. This is why I'm writing member and all that. But and I should probably rename this guy now that I think about it. I have LSIM pointer, LSIM enum, LSIM struct, and this here is more like LSIM primitive match, really, or type definitions or variable declarations. Well, yeah, it's a bit complicated because of the fact that it's for two types. Really, what a terrible, terrible system this is. This whole RST data format is garbage. Just the very fact that it has exactly the same type for matching, like for both declarations of types and type definitions and variable declarations, it's just garbage. Anyway, yeah, it is what it is. So let's say we say if this is a member, I don't want to say, I would call it member LSIM now. Isn't that nice? Otherwise, And then this is where I would use the LSIM match of, okay, and this would not be this guy here, let's be here like this. And I would use reuse my pointer stuff here. See? Like that. And then here else would be unexpected, right? It could be like, I don't expect this to happen. Am I even using fail? Maybe I would even just go as far as saying assert or just fail. Don't expect this to occur. Not fail? Yeah. Why is it doing this weird? Oh, hold on. There we go. So let's say I had this. So at this point, and in either case, I would have this guy up here. So it would be a variable name. So one thing is we want to assert here that this has to be not a type def. If false, this is a variable declaration. It's basically a member variable declaration, right? So we have that there, and as for type, we can actually just set it to the type. Actually, we'd have to find it. So yeah, this is what we do. We'd say I mean, honestly, this is going to be quite similar to what I have already up here. Yeah, right here. And then I want the pass that in there. So that sets this local member type here. Now, if it's a pointer, this is the part that I want to reuse some code. So pointers, the thing with pointers is that it's both a type declaration and a variable type definition and variable declaration in both. That's why over here I have this code. So I'm pretty much going to do exactly the same here. That's why I'm thinking add this. Anyway, let me see. So let me keep this up here on the screen. So what do we want to do? We want to first find the type that this is a pointer to and create a new type for it. Exactly. know what? Let me. I'm looking at the way I name these things. I think I should call this. So it would be something like this. I just want to see how similar they end up looking, and then I could probably factor it out. We add the type here, which basically means this comes up here. Did I not have a... Thought I had something that said that this stack offset was the LSIM value. Maybe I deleted it. Nope. Anyway, so we do this with the type defined, type def ID here. So now we have our type, right? And this becomes our member type, actually. Oh yeah, and I forgot the member.name. Okay. Then once this is done, I have my type here. So I don't need to find it anymore. So actually, in that case, I can set member.type directly. There's no need for me to store it like this. Let's leave it there. Here, same idea. Or you know what? Let me go back to doing it this way. So what we'll do is like this. Okay, similarly, well, actually, yeah. Okay, that's fine. There's some symmetry there, but so we already defined for the thing we point to, and then we create a type. So obviously we have this type. All right, let's see. And then at that point, we just grab the offset bits, the size bits. We don't do this anymore. And we push back the member. So yeah, so there's a little bit of reuse here. I could make this a little bit tighter, this code, if I push define type into there. But then again, I don't know. I'm not completely against this kind of code here. Finding, adding, there's a symmetry to it, and it's not too many lines of code. So I think I'm okay with that. Okay, so for this to work, we're gonna have to rework the values match that I have up here, like I said earlier. Or is it? Here. So we're looking at basically this whole thing with a colon, right? So yeah, it's pretty simple, really. We just match like this. That's it. So yeah, it's no longer member name and type ref ID. This becomes the, like, what did I call it? The lsim something? Lsim var? The lsim, yeah. And this becomes 1, 2, and 3. So it compiles, which is great. Let me just put a breakpoint in here. Are you using reclass? What's reclass? Oh, resharper. No, I'm not using it. So let me check here my CMake targets. What exactly is this? I love how it said this is a port of reclass, but what is reclass? Is it from C++? Tool for reconstructing data. So this must be the original. Ah, it's a tool for reverse engineering data structures in memory. Oh, okay. Right. I think I heard about this guy. Class usable in C, which makes writing code for use in an injected DLL much easier. Oh, that's cool. So basically, it's like a hex editor, and it is able to show you the data structures of your file data. Nice. You can use it to edit files. It's a good hex editor. Ah, very nice. All right, so let me see here. This should actually parse what I have here, and I should hit this guy for the data member D, E, and then P. Edit live memory. Oh, that's cool. That sounds like a useful tool. I suppose that's useful for cracking software and stuff like that. Okay, so what I got here, values, I should have 3. Yep, okay. Let's go through. X:7. So I'm going to start populating a member here. This should match the first one, and it does. It is not a type definition. Should find the type in there, which I do. Hacking not easy anymore with virtual machines and side programs. Yeah. Okay, that's the first member. That's Y. So what do I have here again? Oh, we're doing bar right now. Oh, okay. Forgot about bar. The next one will be Z. Very nice. Okay, F5. Here's my next one. This guy should be, yeah, there's the big one. All right. How many do I got there? Yeah, it's a whole bunch. So I should match a bunch of these. Let me see here. 1, 2, 3, 4, 5, 6 on the 7th one. So I think this is the second. Put a breakpoint in there. Third, fourth, fifth, sixth. We're looking at E. Yeah, so the next one should be P. So let's see if this works. Oh, that didn't work. Why didn't it work? You look at my call stack. Oh, whoops. Another reason why I should be putting these inside their own functions, is I can't reuse variables from outer scopes. All right, let's try that again. One, two, three, four, five, six. So the next one should be the pointer. Boom. All right. Let's see. We should find the type that we are referring to, which is int. It's a primitive type. Name int, so because we have a pointer to int here. And we go ahead and add the indirect type for our pointer. *7, because that's our first time we see a pointer to that type. Fact. Just curious. Yeah, it's making me wonder something. All right, and then we get our name here, P, and we get our type, which is our indirect pointer to an int, right? And then we're good. Okay, so let's see now. My question in my mind here was, after I did this, was what happened if I would declare another pointer? Let's see here. Like in here, or in main. So here it's no longer a declaration. It says you point to type 28, and type 28 is this type here. And if I didn't have this pointer up here, this would disappear, and I'm wondering if it'll say equal to *7 at the bottom here. Yes, it does. It's actually, it becomes a new type 29 in that case for whatever reason, but the equal to, so at least it only, I can rely on the debug info only ever making a pointer declaration once for the first time it sees that type. So here in star, if it's seen as the first time it's seen as a data member, it's going to put the equal *7 up there. So that's good. All right, so let's see if this actually shows us a pointer. There we go. We have our P here. So we should actually set it to something, so it'd be actually useful to see if it works. F.P is equal to, I don't know, address of F.A. How about that? Oh no, A is not an integer. I need an integer. So P has whatever garbage is in there, and then here we assign it to the address of F, which then it now shows 12 here in the dereferenced value, and if we assign through it, we should see both those change. And there you go. So we now support pointers in our data, in our structs. So what this means is that technically what we can do with this is yeah, I don't think I can still do the self-referencing thing because of the forward declaration, I think. Maybe. Maybe not. So what I'm thinking about is like basically like a linked list. So if I did something like this, so I don't think this will work, but let's just try it. So let's go like N3, N2, and N1, address of N2. And the reason I think this won't work, in fact, I should be able to just look here and see. So let's see here, we've got, no, not the constructor, the type declaration up here. Yeah, this is the self-referential thing. See, like, node is type 29. It is a struct with two, is that the size, I think, which is 2 bytes, which makes sense because a pointer is 2 bytes on this platform. It has a member called next, which is a pointer. We can see that here. So it has type 30 itself. So this is the first time we declare a pointer. So the type for that will be 30. And it's equal to a pointer of type 29. And now 29 is what we're defining here. So this, I don't yet support that, and I have that in my to-do list. Add support for self-referential types. I actually gave this example here. So yeah, let me move this up because I'd like this to work. So right now, if I run this, I'm gonna get like, basically I think I'm gonna get nothing for my, see, I'm not gonna even have node in here because it's a type that failed to parse, and I should actually see it in my error log, which, where is that? Data, dev, print stream, I think. It's unfortunate that Visual Studio won't open that file. Let's do this. One second. Yeah, so we can see it here. So while it's parsing, it's saying type not found for next, type ref ID 29, type not found for N3, N2, N1. So these here are failing to work because the type that it's looking for with the ref 29 is in the process of being defined, and so it's not finding it. I think I thought about this a little bit last time. I need to, like, if I see a type I don't have yet, it's got to go into some kind of bucket of, you know, types that will be defined. and I'm not quite sure like what I do for that, but because I want to be able to create my variables or members and have them have a type, but this type is not yet defined. And if I don't know what the type is, yeah, this is the same problem I think as for declarations. I mean, for pointers in particular, it's not a huge problem, but just a general problem. So I need to think a little bit about this. But you know what? I'm pretty happy that we got pointers working. Does this here add support for pointers? And I think that the refactoring we did today, which allowed me to do this, makes it not too bad. I still think I'm going to refactor all of these cases here into their own functions, and it's going to even help. It's going to help even more to clean this mess up. Parse member variables as we do regular variables. We expect these to only match. We expect these to be either regular variable declarations or pointer, or I guess indirect. Pointer no, not declarations. Yeah, no, it is that. Or oh yeah, that's what I want to say. Pointer type definition. All right. Why is it A18 again? Oh, float, right. Guess I was looking at a different type when I wrote this out. Okay, anyway, whatever. All right, so what we got here? We're going to say Rst Parser or something like, yeah, let's see. Parse pointer members of structs correctly, or add support correctly parse, or I don't know what to say here, add support for struct pointer members. This change, a struct with a pointer will be parsed properly and the pointer member displayed in the debugger. All right. So this is done. So yeah, I could work on this next time. Could also do the bit field thing. I have to mess around with virtuals and all this, member functions. All right, well, I think this is a great place for me to stop. I'm very happy with this progress. I think the refactoring was totally worth it. So yeah, I'm going to stop here, guys. So thanks for watching, and I should be back next week. This week on Thursday. So in like a couple nights. So yeah, thanks a lot for watching, and I'll see you next time.